Dear students, welcome. We are discussing the nth differentiation of some functions. Now, today we are going to start Leibnitz theorem. Leibnitz theorem helps us to find the nth derivative of the product of two functions. Of the product of two functions. First, I am going to give the statement of the Leibniz theorem. Let us see. Leibniz theorem, the statement. If U and V are functions of x such that all their desired differential coefficients exist, such that all their desired differential coefficients exist, then the nth derivative, nth differential coefficient of the product of U and V is given by the nth derivatives of U and V, product of U and V, is given by d to the power n uv. This is equal to d to the power n uv plus nc1, d to the power n minus 1 u dv plus nc2, d to the power n minus 2 u d square v plus nc3, the n minus 3 times differentiation of u and 3 times differentiation of v plus, and the general term will be ncr d to the power n minus r u, the n minus r is derivatives of this, and r times differentiation of v plus, and finally we will get ncn u, the nth derivatives of v. This is the statement of the Leibniz theory. This is the statement of Leibniz theory. The nth differentiation of product of u and v, this is equal to nth differentiation of u into v plus nc1, n minus 1th differentiation of u into first derivative of v plus nc2, n minus 2 times the differentiation of u into second derivative of v, and proceeding in this way, and in the last term we will get ncn u, the nth differentiation of v. This can be written as uvn. This is equal to u and v plus nc1 u n minus 1 v1 plus nc2 u n minus 2 v2 plus nc3 u n minus 3 v3 plus dot 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 ncr u n minus r vr plus dot dot dot, and finally last term is ncn uvn. This can be written as this also. This theorem is very important to find the nth derivatives of the product of two functions. to find the nth derivative of the product of two functions. Now, proof of the nth differentiation, proof of the Leibniz theory, proof. We shall prove the Leibniz theory by the method of mathematical induction. Mathematical induction. By the method of mathematical induction. The Leibniz theorem is the Leibniz theorem is UVN. This is equal to UNV plus NC1 plus NC1 UN minus 1 V1 plus NC2 UN minus 2 V2 plus NC3 UN minus 3 V3 plus. In this way, the nth term, the rth term is middle term, NCR UN minus R VR. The term just after this, NCR plus 1 U N minus R minus 1 V R plus 1 plus dot. And finally NC N minus 1 NC N minus 1 U1 Vn minus 1 plus NCN U Vn. Will get this. Also, the term just before this will be definitely NCR minus 1 UN minus R plus 1 VR minus 1 VR minus 1. This is the statement of Leibniz theorem. We shall prove the Leibniz theorem by the method of mathematical induction. Suppose this is number 1. This is number 1. Now, for n equal to 1, left hand side of 1, this is equal to UV1. This is nothing but d of UV, which is equal to, this stands for ddx. UV, even VR functions of x. This is equal to du dx v plus u dv dx. This is equal to u1 v plus uv1. u1 v plus uv1. For n equal to 1, this is equal to the right hand side of 1. This is equal to right hand side of 1. For n equal to 1. For n is equal to, this is 1. This is equal to right hand side of 1. For n is equal to 1. Therefore, 1 is true. For n equal to 1. 1 is true for n is equal to 1 is true for n is equal to 1. Now let us suppose that n is equal to n, 1 is true for any value of n. Integral value this is equal to 1. Therefore, 1 is true for n equal to 1. Leibniz theorem is true for n is equal to 1. That is, Leibniz theorem is true for n is equal to 1. That is Leibniz theorem theorem is true for n is equal to 1. Leibniz theorem is true for n is equal to 1. Let us suppose that n is true for any value of n for n is equal to n. Suppose this is true for n is equal to n. Therefore, we suppose that 1 is true. 1 is true. That is, we suppose that 1 is true. That is, 1 is true. We suppose that. That is, we suppose that. That 1 is true. 1 is true. Now, differentiating both sides of 1 with respect to x, we get. Now, differentiating both sides of 1 with respect to x. Differentiating both sides of 1 with respect to x, we get. Differentiating both sides of 1 with respect to x. Here u and v are functions of x. Now, this term will be required later. Therefore, I am writing like this. Differentiating 1 with respect to x, we get u v n plus 1. This is equal to, this is the product function. U and v is the product function. First, differentiate the first function, u n plus 1 v plus u n v1. We can write like this for first term. First term is this plus nc1. The differentiate the second term, this un minus 1 times. If we differentiate it with respect to x, then we will get un v1 plus un minus 2 v2, un minus 1 v2, un minus 1 v2. Right? Next, nc2, differentiate this, un minus 1 v2 plus nc2, un minus 2 v3, differentiate this one, plus nc3 differentiate this, un minus 2 v3 plus n minus 3 v4 plus. Now this term ncr minus 1, ncr minus 1, differentiate this, un minus r plus 2, n minus r plus 2, v r minus 1 plus un minus r plus 1 vr. This term will be this plus ncr. Differentiate again with respect to x. You will get n minus r plus 1, un minus r plus 1 vr plus un minus r v r plus 1, Up to these terms I have written this. Up to this term. Next, this term will be I am writing this term in here. Plus nc r plus 1 NC R plus 1. Differentiate this UN minus R. UN minus R. UN minus R. VR plus 1. R plus 1. VR plus 1 plus UN minus R minus 1. Differentiate this VR plus 2. VR plus 2 this plus NC N minus 1. Here differentiate this into Vn minus 1 plus U1 Vn U1 Vn plus NCN U1 Vn plus UV N plus 1 UV N plus 1 UV N plus 1, this is equal to this. This is equal to this, and it stops at this. In this. This can be written as, now UVN plus 1. This is equal to, write the first term UN plus 1V plus these two terms can be joined. UN V1, UN V1. 1 plus NC1. 1 plus NC1 UN V1 plus join these two terms UN minus 1 V2 NC1 plus NC2 NC1 plus NC2 UN minus 1 V2 UN minus 1, this is V, this is V2 plus next term will be this term UN minus 2 V3 UN minus 2 V3 NC2 plus NC3 UN minus 2 V3 UN minus 2 V3 UN minus 2 V3 plus dot dot dot. Now we shall write here. Now write this term. This term UN minus R plus 1 VR UN minus R plus 1 VR plus NC R minus 1 plus NCR UN minus R plus 1 VR plus 1 VR plus next terms this term and this term, this term and this term. What will be this? NCR NCR UN minus R VR plus 1 VR plus 1 no NCR plus NCR plus 1 UN minus 1 UN minus R VR plus 1 VR plus 1 and finally plus plus write these two terms U1 P1
1
U1 Vn. This is not V1. This is Vn. These two terms. Write these two terms. NCn minus plus NCn. NCn minus 1 NCn. Un Vn. U1 Vn plus last term is NCn. NCn UVn plus 1. UVn plus 1. Perhaps you understand this. You see? Now, this term and this term, I will remove this. One Now, let me remind you one formula. Let me remind you, you have already got NCR plus NCR minus 1. This is equal to N plus 1 CR from algebra. NCR plus NCR minus 1, this is equal to N plus 1 CR. Or NCR plus NCR plus 1, you will get N plus 1 CR plus 1. From combination chapter in class 12 you have got this. NCR plus NCR minus 1, this is equal to N plus 1 CR. Now, see here. One is NC0. NC0, we have, you be right here, we have this. NCR plus NCR minus 1 equal to N plus 1 CR. NCR plus NCR plus 1 equal to N plus 1 CR plus 1. Therefore, 1 plus NC1, this is equal to NC0 plus NC1. This is equal to N plus 1 C1. You will get this one. N plus 1 C1. You will get this one. N plus 1 C1. Also, for this, N plus 1 C1. Next, NC1 plus NC1 plus NC2. It will be equal to N plus 1 C2. N plus 1 C2 plus and NC2 plus NC3. This is equal to N plus 1 C3. You will get this. N plus 1 C3. You will get this. You will get this one. You will get this one. Next, this one, NC R minus 1 plus NCR. This is equal to N plus 1 CR. N plus 1 CR. You will get this one, N plus 1 CR. NCR plus NCR plus 1. NCR plus NCR plus 1. This is equal to N plus 1 CR plus 1. You will get this. NCN minus 1 plus NCN. This is equal to N plus 1 CN. N plus 1 CN. You will get this one. Therefore, these terms can be written as. Therefore, these terms can be written as. Remove this term. Remove this one. This means this, ultimately this, and I am writing this. This means UV n plus 1. This is equal to UN plus 1 V plus 1 plus NC 1 equal to N plus 1 C1. C1 UN V1 plus, for this NC1 plus NC2, this is equal to N plus 1 C2. UN minus 1 V2 plus this is equal to n plus 1 C3 u n minus 2 V3 u n minus 2 V3 plus, proceeding in this way, plus, just write this term n plus 1 C r plus 1 C r plus 1 u n minus 1 u n minus r v r plus 1 v r plus 1 plus, and it will get n plus 1 C n plus 1 C n u 1 v n plus this is equal to u v n plus 1 and C n, this is equal to 1 u v n plus 1. You will get this. You will get this one. You will get this one. This means u v n plus 1. This is equal to u n plus 1 v plus n plus 1 C1 u n plus 1 minus 1 v1. You may write it like this. U n plus 1 v1. You may write like this. Minus v1 plus n plus 1 C2 n plus 1 C2 u n plus 1 minus 2 v2. You may write like this. N plus 1 C2 u n minus 1 is 1, n minus 1 can be written as n plus 1 minus 2 plus n plus 1 C3 u n plus 1 minus 3 v3 plus dot dot. Write this term n plus 1 C r plus 1 u n plus 1 minus r plus 1 v r plus 1 plus dot 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 n plus 1 C, this can be written as n plus 1 C n u n plus 1 minus n plus 1 minus n vn plus, it is nothing but n plus 1 C n plus 1. This is also 1 u v n plus 1. You may write like this. You may write like this. Now observe this one. The Leibnitz theorem is u v n. This is equal to u n v plus n C1 u n minus 1 v1 plus n C2 u n minus 2 v2 plus n C3 plus n C3 u n minus 3 v3 plus n plus the common term is NCR u n minus r vr, and finally we will get u v n. You may write NCN u v NCN u v n. Now notice this line. Notice this step. Just n is replaced in the Leibniz theorem 1. Thus we have replaced n by n minus 1 in both sides. N by n minus 1 in both sides. We have replaced n by n plus 1 both sides. It was UVN, we have written UV n plus 1. UNV, we have written n plus 1. NC1 UN minus 1 V1. Just we have replaced n by n plus 1. Just we have replaced n by n plus 1. We have replaced n by n plus 1. Therefore, if we suppose that the Leibniz theorem is true for n, then it is automatically true for n equal to n plus 1 also. Thus, Thus, if we suppose that 1 is true for n, that is 1 is that is Leibniz theorem is true for n. Theorem is true for n. True for n. Then it is true for n plus 1 also. Just notice that. Just notice it. Just n is replaced by n plus 1 in Leibniz theorem. But 1 is true for n equal to 1. 1 is true for n is equal to 1. Therefore, just we have proved 1 is true for n is equal to 1 plus 1 also. Therefore, 1 is true for n equal to 1 plus 1. This is equal to 2 also. Since it is true for n equal to 2, since it is true for n is equal to 2, therefore it is true for n equal to 2 plus 1, this is equal to 3 also, and so on. And so on. Hence, by the principle of mathematical induction, the Leibniz theorem is true. Thus, by the principle of Leibniz theorem, Leibniz theorem, 1 is true for all n. For all n means Leibniz theorem is true for it is positive integer. For positive integer. It's true for it. Thus, Leibniz theorem is true. We have proved the Leibniz theorem. Leibniz theorem will help us to find the product of find the nth derivatives of the product of two functions. It will help us to find the nth derivatives of the product of two functions. Product of two functions. Let us take a very simple example. Very simple. We have we shall apply Leibniz theorem. We shall apply Leibniz theorem. If y equal to x to the power n minus 1 log x, find yn. Suppose this. If y equal to x to the power n minus 1 log x, find yn. Find yn. This solution. Y this is equal to x to the power n minus 1. This is suppose example number 1. X to the power n minus 1 log x. X to the power n minus 1 log x. Suppose this is number 1. Suppose this is number 1. Differentiating 1 with respect to x. Differentiating 1 with respect to x. You will get y1 equal to differentiation of this. X to the power differentiation of this n minus 1. X to the power n minus 2 into log x plus x to the power n minus 1 into 1 by x into 1 by x. This means xy1 this is equal to n minus 1 x to the power n minus 1 log x plus x to the power n minus 1. You will get this one. This means xy1 equal to n minus 1 x to the power n minus 1 log x. This is equal to y plus x to the power n minus 1. Suppose this is number 2. This is number 2. And x to the power n minus 1 log x has been replaced by y. Has been replaced by y. This is by 1 using 1. Since y equal to x to the power n minus 1 log x, use it by 1. By 1, y equal to x to the power n minus 1 log x by 1. Now differentiating to, we have to find yn. Therefore, we have to differentiate to n minus 1 times. Differentiating to n minus 1 times by Leibnitz theorem, by applying Leibnitz theorem. Leibnitz theorem. n minus 1 times. Here, this is the product function. xy1, you see, xy1 is the product function. y1, we shall take y1 as vu and x as v. The first function is y1, second function is x. If you differentiate n minus 1 times, just remember the formula, just u v n, this is equal to u n v plus nc1 u n minus 1 v1. Therefore, y1 differentiate this n times, n minus 1 times. Originally it was y1. Therefore, if you differentiate y1 n minus 1 times, you will definitely get yn. Even v is x. I am writing x here. Plus Leibniz theorem nc1. Here we have we are differentiating n minus 1 times. Therefore, it is n minus 1 c1. n minus 1 c1. v1 means x. Differentiate x. 1 time. 1. y. It will be definitely n minus 1. n minus 2 times. Differentiate y1 n minus 2 times. It will be yn minus 1. This is equal to n minus 1. y. Differentiate y n minus 1 times. It will be yn minus 1 plus. What is this? X to the power n minus 1. The nth differentiation. I told you that. d to the power n, dx to the power n, x to the power n. This is equal to factorial n. If you differentiate n minus x to the power n minus 1 times, you will get factorial n minus 1. Factorial n minus 1. You may write here, since d to the power n, x to the power n, this is equal to factorial n. d to the power n, x to the power n equal to factorial n. X to the power n, differentiate x to the power n times, you will get factorial n. Now, this means xyn plus n minus 1 c1. What will be the result of n minus 1 c1? It is definitely n minus 1. yn minus 1. This is equal to n minus 1 yn minus 1 plus factorial n minus 1. These two terms will be cancelled. This means yn, this is equal to factorial n minus 1 divided by x. This is the nth differentiation. Yn, this is equal to this. Yn, this is equal to this. Very easy. No. Example number 2. If y equal to x to the power n log x, x to the power y, this is equal to x to the power n log x. Prove that yn plus 1, this is equal to factorial n divided by x. It will be factorial n divided by x. If y equal to x to the power n log x, this is equal to x to the power n log x, then prove that yn plus 1 equal to solution. why this is equal to x to the power n log x. Number one. Now differentiate 1 with respect to x. Differentiating 1 with respect to x, we get 1 with respect to x, we get y1, this is equal to x to the power n 1 by x plus m x to the power n minus 1 log x. This means x y1, this is equal to x to the power n plus m x to the power n log x. If you multiply by x, then it will be x to the power n, and it will be x to the power n. This means x y1, this is equal to x to the power n plus m x to the power n log x can be replaced by y. This can be replaced by y. Change by 1. You may write it as by 1 and write it as 2. Now differentiating 2 n times. Differentiating 2 n times, we get by n times by Leibnitz theory. We get n times by Leibnitz theory. X, y, n plus 1, n times. Here we are differentiating n times. Therefore, it will be nc1. It will be 1. The differentiation of x is equal to 1. Yn, this is equal to, differentiation of this is factorial n plus nyn. You may write here, since d to the power n dx to the power n x to the power n, this is equal to factorial n. Since this means x y n plus 1, this is x y n plus 1 plus n y n, this is equal to factorial n plus n y n. The two terms will be cancelled. This means y n plus 1, this is equal to factorial n divided by x. Factorial n divided by x. Good. Now notice that after this term, I am not writing the terms after this, because if you differentiate 1 with respect to x, it will be 0. If you differentiate 1, it will be 0. If you differentiate 0, it will be 0. Other terms will be 0. Other terms will finish. Therefore, if you differentiate this n times x y1 n times, then you will get simply this one. Other terms will vary. Now, example number 3. If y this is equal to x cube log x, find y. Y equal to x cube log x, find y. Notice that if you differentiate x cube, then you will get 3 times of x square. If you differentiate 3x square, you will get 6x. If you differentiate 6x, then you will get 6. If you differentiate 6, then it will be 0 and other terms will be 0. Therefore, in this case, we shall take x cube as the second function, log x as the first function, x cube as the second function. X cube as the second function. X cube as the second. Now, why this is equal to x cube log x? Suppose number 1, differentiating 1 n times. Differentiating 1 n times. Differentiating 1 n times by Leibniz theorem, by applying Leibniz theorem. We get yn, this is equal to yn, this is equal to uvn. The nth differentiation of this it will be second u n times log x cube d to the power n log x cube d to the power n log x, or you may write like this, plus nc1 d to the power n minus 1 log x 3x square plus nc2 log x 6x plus nc3 n minus 3 log x into 6. Other terms will vanish. Other terms will vanish. Other terms will vanish. This means yn this is equal to yn this is equal to. Now, what is the nth differentiation of log x? What is the nth differentiation of log x? You see, suppose y equal to log x, y1 this is equal to x to the power minus 1, y2 equal to minus 1 x to the power minus 2, y3 is equal to minus 1 minus 2 x to the power minus 3, y4 equal to minus 1 minus 2 minus 3 x to the power minus 4. You will get like this. Therefore, yn will be equal to minus 1 whole to the power n minus 1 factorial n minus 1 divided by x to the power n. Am I right? Y to the power yn this is equal to minus 1 whole to the power n minus 1 factorial n minus 1 x to the power n. You will get minus 1 whole to the power n minus 1 factorial n minus 1 divided by x to the power n into x cube, x to the power n into x cube plus nc1 means n into 36 square. You may write n into 36 square. What will be the log x? N minus 1 times differentiation. You are differentiating n minus 1 times. You will get this one. You will get this one. You will get this one plus you will get this one thrice n x square minus 1 whole to the power n minus 2 factorial n minus 2 divided by x to the power n minus 1. You will get this one plus nc3 by nc2. nc2 means n into n minus 1 divided by 2. It will be minus 1 whole to the power n minus 3 factorial n minus 3 divided by x to the power n minus 2 into 6x. You will get this plus NC3 you will get NC3 n into n minus 1 into n minus 2 divided by factorial 3 For this you will get minus 1 whole to the power n minus 4 factorial n minus 4 divided by x to the power n minus 3 into 6. X to the power n minus 3 into 6. You will get this one. And other terms will vanish. Other terms will vanish. Other terms will vanish. Now this one. Now you see here, if you take x cube in the denominator, then you will get x to the power n minus 3. You will get x to the power n minus 3. Here also, x square, if you take x square in the denominator, you will get x to the power n minus 3. Here also you will get x to the power n minus 3. It is already x to the power n minus 3. Therefore, x to the power n minus 3. This means yn. This is equal to yn. This is equal to yn equal to also here see this 6 will be cancelled n minus 1 by x to the power n minus 3. This is common. X to the power n minus 3. This is common. Also x to the power n minus 3 common, minus 1 whole to the power n minus 1. Take this also common. Then you will get here n minus 1 factorial, n minus 1. You will get factorial n minus 1 plus these terms we have already written. Thrice into factorial n minus 2. Thrice into factorial n minus 2. Minus 1 whole to the power n minus 1. If you take this common, then it will get you will get here minus sign. You will get minus sign. Thrice n minus 2 factorial. Here minus 1 whole to the power n minus 1 common, it will be plus, and this you will get here 3 plus 3 n into n minus 1 factorial n minus 3 factorial n minus 3. You will get this one plus finally here you will get plus minus 1 whole to the power n minus 1. It will be minus 1. If you take minus 1 whole to the power n minus 1, you will get minus n into n minus 1 into n minus 2 into factorial n minus 4 into factorial n minus 4. You will get this. You will get this. This means this is equal to minus 1 whole to the power n minus 1, x to the power n minus 3. Here n minus factorial n minus 1 minus, here you see, if you multiply here numerator and denominator by n minus 1, then this term will be n into n minus 1 into factorial n minus 2. It will become factorial n. It will become factorial n. Therefore, minus 3 times of factorial n divided by n minus 1. Factorial n divided by n minus 1. You will get this one. Plus 3 times of, if you multiply numerator and denominator by n minus 2, then you will get 3 times of n minus 2 divided by n, you will get factorial n divided by n minus 2. Factorial n divided by n minus 2. Plus minus, if you, it will be factorial n divided by n minus 3. It will be like this. It will be like this. Now, this is equal to minus 1 whole to the power n minus 1, x to the power n minus 3. You may write here, factorial n divided by n. Factorial n can be written as n into factorial n minus 1, and n will be cancelled this. Minus 3 factorial n divided by n minus 1 plus 3 factorial n divided by n minus 2 minus factorial n divided by n minus 3. You may write like this. This is equal to minus 1 whole to the power n minus 1. Factorial n can be taken common outside. It will be 1 by n minus 3 by n minus 1 plus 3 by n minus 2 minus 1 by n minus 3. 1 by n minus 3. You may write like this also. You may simplify also. Then there will be no problem. You may simplify also this one. That there will be, you may write like this also. In such way, we can find the analytic differentiation. In such way, we can find the analytic differentiation. Now, example number 4. Now, example number 4. If y equal to, suppose this is x cube cos x, find yn. X cube cos x, find yn. Y equal to x cube cos x, then find yn. Find yn. Now, the nth differentiation of cos x, y equal to cos x, then yn equal to cos of n times of pi by 2 plus x. You should remember this. Now, given that y this is equal to x cube cos x, x cube cos x, differentiating 1, n times by Leibnitz theorem, we get differentiate 1 n times by Leibnitz theorem. One n times by Leibnitz theorem. Yn, this is equal to UNV cos of n times of pi by 2 plus x into v means x cube plus nc1 plus NC1. Un minus 1 V1 cos of n minus 1 times of pi by 2 plus x. V1 means thrice x square plus NC2 cos of n minus 2 times of pi by 2 plus x into 6x plus NC3 cos of n minus 3 times of pi by 2 plus x 3 times of pi by 2 plus x into 6. Other terms will vanish. Other terms will vanish. You may write here, other terms will vanish. Other terms will vanish. Other terms will vanish. Now, write it here number 1. Suppose this is number 1. This is number 1. Now, what will be this term? Cos of n minus 1 times of pi by 2 plus x. Now, cos of n minus 1 times of pi by 2 plus x. This is equal to cos of minus pi by 2 plus n times of pi by 2 plus x. You may write like this also. You may write like this. This is equal to cos of minus cos of pi by 2 minus n times of pi by 2 plus x. You may write like this also. This is equal to sin n times of pi by 2 plus x. This is equal to sin n times of pi by 2. This term can be written as sin of n times of pi by 2 plus x. Sin of n times of pi by 2 plus x. Now, what will be this term? Cos of n minus 2 times of pi by 2 plus x. This is equal to cos of minus pi plus n times of pi by 2 plus x. N times of pi by 2 plus x. This is equal to cos minus cos of pi minus n times of pi by 2 plus x. You may write like this, which is equal to, this is equal to minus cos n times of pi by 2 plus x. Minus cos of n times of pi by 2 plus x. Now this term, what will be this term? Cos of n minus 3 times of pi by 2 plus x. Cos of n times of n minus 3 times of pi by 2 plus x. This is equal to cos of minus thrice pi by 2 plus n times of pi by 2 plus x. You may write like this. This is equal to cos of thrice pi by 2 can be written as pi plus n times of pi by 2 plus x. Pi minus pi plus this minus you may write like this, cos pi plus, this is equal to minus cos pi by 2 minus n times of pi by 2 plus x. This is equal to minus sine n times of pi by 2 plus 6. N times of pi by 2 plus 6. Right? Minus sine n times of pi by 2 plus 6. Now 1 in place. Now 1 in place. Therefore, from 1 you will get yn, this is equal to, this is unchanged, cos of n times of pi by 2 plus 6 into x cube. For this, we have got sine of n times of this, plus nc1 means n, thrice n x square, thrice n x square, sine of n times of pi by 2 plus 6, n times of pi by 2 plus 6. Next, this term, what will be this term? Plus n into n minus 1 divided by 2 into 6x, into 6x, this 6x. What is this? Cos of n minus 2 pi by 2, this is equal to minus cos of n times of pi by 2 plus x, cos of n times of pi by 2 plus x. And finally, this term, plus n into n minus 1 into n minus 2 divided by factorial 3 divided by 6 into again 6. What is this? Minus sine n times of pi by 2 plus 6, minus sine n times of pi by 2 plus 6. Now see, yn this is equal to, yn this is equal to, where is cos of n times of pi by 2 plus 6? Cos of n times of pi by 2 plus 6. Yeah, it will be 3 x cube, it will be x cube minus n into n minus 1 minus 3 times of n into n minus 1 x into cos of n times of pi by 2 plus x, this is x, n times of pi by 2 plus x, right? Now sine n times of pi by 2 plus x, sine of n times, this 6 will be cancelled, this 6 will be cancelled, plus n times of thrice x square minus n minus 1 n minus 2 n minus 1 n minus 2 sine of n times of pi by 2 plus 6, sine of n times of pi by 2 plus 6. Pi by 2. This is the nth differentiation. This is the nth differentiation. Answer this. Let us take another problem. Let us take another problem. If y this is equal to a cos log x plus b sin log x, y equal to a cos log x plus b sin log x, then show that x square yn plus 2, then show that plus twice n plus 1 xyn plus 1 plus n square plus 1 yn. This is equal to 0. N square plus 1 yn. This is equal to 0. N square plus 1 yn. This is equal to 0. Now solution. Y this is equal to a cos of log x plus b sin log x. B sin log x. Suppose this is number 1. Suppose this is number 1. Differentiating 1 with respect to x, we get. Differentiating 1 with respect to x, we get. Y1 this is equal to minus a sin log x into 1 by x plus b cos log x into 1 by x. This means xy1 this is equal to minus a sin log x plus b cos log x. B cos log x. Suppose this is number 2. Suppose this is number 2. This is number 2. Differentiating 2 with respect to x. Now differentiating 2 with respect to x. X we get. Differentiating 2 with respect to x we get. xy2 plus y1 this is equal to minus a cos log x into 1 by x minus b sin log x into 1 by x. This means x square y2 plus xy1 this is equal to minus a cos log x plus b sin log x. A cos log x plus b sin log x. By 1 this can be replaced by y. By 1 this can be replaced by 1. X square y2 plus xy1 this is equal to minus 1 by 1 using 1. This means x square y2 plus xy1 plus y this is equal to 0. Suppose this is number 3. Now differentiating 3n times. Differentiating 3n times by Leibnitz theory. We get. Differentiating 3n times by Leibnitz theory. We get. n times by Leibniz theory. Now, u and v differentiate y to n times, you will get, if you differentiate y to n times, you will get yn plus 2 into x square plus nc1 differentiate x square n plus 1 differentiate y to n minus 1 times, you will get yn plus nc2 2 yn plus x yn plus 1 plus nc1 into 1 yn, you will get this plus again yn, this is equal to 0. Yn, this is equal to 0. Perhaps you understand this. This means x square yn plus 2. See, x yn plus 1 x yn plus 1. These two terms will be common. Plus it will be n. This is nothing but n. This is equal to n. Twice n plus 1 times of x yn plus 1 plus what is this? This is equal to n into n minus 1 divided by 2. Therefore it will be n into n minus 1 from this plus what is this? This is equal to n plus n plus 1 yn. This is equal to 0. This means x square yn plus 2 plus twice n plus 1 x yn plus 1 plus this n will be cancelled, n square plus 1 yn. This is equal to 0. N square plus 1 yn. This is equal to 0. Proved. Last problem. Perhaps to this. Perhaps this number 6. If number 6 or number 5 or like this. If y this is equal to e to the power a sin inverse x. Prove that. Prove that. 1 minus x square yn plus 2 minus twice n plus 1 x yn plus 1 minus n square plus a square yn. This is equal to 0. Suppose this is we are asked to prove this one. Y equal to e to the power a sin inverse x. Prove that this y is equal to a sin inverse x. Prove that. Solution. Y this is equal to e to the power a sin inverse x. This means differentiate this with respect to x. E to the power a sin inverse x a divided by root over 1 minus x square. Simply we will get this. Here we made a differentiating with respect to x. With respect to x. Differentiating with respect to x, you will get this. This means y1 this is equal to, it can be replaced by y. Ay by root over 1 minus x square by 1. If I get it as 1. This means 1 minus x square y1 square. This is equal to x square y square. Suppose this is number 2. Differentiating 2 with respect to x. With respect to x. 1 minus x square. If you differentiate this twice y1 y2 plus, not plus, it will be minus, twice x into y1 square. This is equal to a square twice y1. 2 is not equal to 0, therefore y1 is not equal to 0. y1 can be cancelled from both sides. This means 1 minus x square y2 minus x y1 minus x square y. This is equal to 0. Suppose this is number 3. This is number 3. Now differentiate 3 n times by apply Leibnitz theorem. Differentiating 3 n times by Leibnitz theorem. We get by Leibniz theorem we get simple 1 minus x square yn plus 2 plus nc1, it is minus twice x, yn plus 1 plus nc2, it is minus 2 yn plus minus, it is minus x yn plus 1 minus nc1 into 1 yn minus a square yn, this is equal to 0, n times this means 1 minus x square yn plus 2 minus twice n x, simple, yn plus 1 minus n into n minus 1 yn minus x yn plus 1 minus n yn minus a square yn, this is equal to 0. This means 1 minus x square yn plus 2 minus twice n plus 1 x yn plus 1 minus n into n minus 1 plus n plus a square yn, this is equal to 0. This is equal to 0. This means 1 minus x square yn plus 2 minus twice n plus 1x yn plus 1. This plus and minus n will be cancelled, minus n square plus a square yn, this is equal to 0. N square plus a square yn, this is equal to 0, proved. In such way, we apply Leibniz theorem to find the nth differentiation. Nth differentiation of product functions. Perhaps you understand this, dear students. I want to stop here. Thanks for attending the class. Thank you.